So now we're going to calculate some normal probabilities in an applied situation. We are looking at some blood sugar levels here. We are assuming that they are normally distributed. They have a mean of 105 and a standard deviation of 12. So that's telling us that mu is 105 and sigma is 12. So population mean and standard deviation. We want to find the probability that a randomly selected person will have a blood glucose level that is greater than 110. So what we are asking in symbols is what is the probability that X, our blood sugar level, is greater than 110. Let's sketch a picture of the normal distribution to help us decide what we want to do here. So we've got this normal distribution of blood sugars. 105 is in the middle, and we want to know what's the probability that the blood sugar level is greater than 110. So 110 is a little to the right of 105, maybe right here, and that probability is given by an area on the normal distribution right here. So we can use normal CDF to compute this. So this is going to be normal CDF. And then remember, it's lower bound, upper bound, mean, and standard deviation is our syntax there. So our lower bound, our left cutoff is 110. Our right cutoff here, this goes all the way to the right, so that would be infinity. We're going to use 10,000. And then we want mean and standard deviation on the end. And our mean is 105, and our standard deviation is 12. So let's go ahead and plug that into the calculator. So we go to second variables, distribution menu, normal CDF is number 2, and then our lower cutoff, 110, our upper bound is 10,000. Remember, we're just picking a big positive number in place of infinity. Mean, 105. Standard deviation sigma is 12. Paste it. 0.3385 to 4 decimal places. So that means there's a 33.85% chance that a randomly selected person would have a blood sugar level that is greater than 110. So a blood sugar level that falls over here on the normal curve. What's the probability that their blood sugar would be between 90 and 120? So in symbols, this is saying probability 90 less than X, less than 120. So on the normal distribution curve, we've got our 105 in the middle, and then 90 down here, and 120 someplace up here. And that probability is represented by this area on the normal curve, and we can use normal CDF to compute that. So this again will be normal CDF. Our lower bound, lower cutoff 90, upper is 120, so 90 comma 120, and then mean standard deviation, 105 and 12. Go ahead and plug that into the calculator. So we'll do second variables again, number 2, and we just have to change our lower and upper. Mean and standard deviation are the same. So lower will be 90 now, upper 120, paste it, evaluate 7887. So there is a 78, almost 79% chance that a randomly selected person's blood sugar would be between 90 and 120. And then less than 95, so that's asking probability that X, that randomly selected person's blood sugar level, would be less than 95. So if we sketch our normal distribution, 105 is in the middle, that's our mean. 95 somewhere to the left. And then we want probability less than 95, so that's represented by the area to the left of 95. So our lower cutoff would be negative infinity. We'll use negative 10,000. So normal CDF again. And then let's move this down, give ourselves a little bit more room. Negative 10,000 for our lower bound. And then upper bound would be 95. Mean and standard deviation the same. 105 and 12. Plug that into the calculator. So second variables, number 2, lower bound, negative 10,000, upper 95, mean and standard deviation the same. 2023 rounded. So there is a 20.23% chance that a randomly selected person's blood sugar is below 95. So that's how we do applied problems. You don't have to draw the normal distribution, but I think it's very helpful most of the time because it gives you an idea of picture of what your lower bound and upper bound should be. Greater than, you shade to the right, less than to the left, and then a between, you're shading between the two cutoffs.